Have you ever wondered what you would do if the zombie apocalypse started and you had no power? Well, that's probably just me, but this is day 2 of easy Arduino projects you can code at home. And for today, we have an efficient night light that increases and decreases its light level in correspondence with the light in your room and environment. So let's jump right into it with what you'll need to make this. You'll need a microcontroller, for which I've used the Arduino Uno R3. You can use any model you like though, such as the Arduino Nano or the Arduino Mega. Next, you'll need a breadboard to keep those wires easy and organized. You'll need a photoresistor, which will tell the light level of the room to your Arduino, and the LED, which will emit the light based on that level. We'll need jumper cables to connect it all, and the Arduino IDE to code this. So let's get started with the wiring. We'll connect a photoresistor for the first leg to the 5-volt terminal, and the second leg to not just the analog pin 0 to give the signal and the amount of light in the room, but also using a 10 ohm resistor to the negative terminal to complete the circuit. Then for our LED, we'll use the anode or the long end, also known as the positive terminal in some cases, to the digital pin 9, which is a PWM pin, which we can get with the tilde on it. The PWM pin basically stands for how a pin manipulates the power going to the LED in a way that you'll think its power is at a certain percentage by turning it off and on really quickly. For example, turning it off and on at a speed can make you think that it's running at 50% of its true power. But enough of that, and now we'll take the cathode or the short leg and connect it using a 10 or 220 ohm resistor to the negative terminal. So with the wiring done and all set, you can feel free to pause the video to make sure your wiring is perfect, and then we'll move on to the coding. So in the Arduino IDE, we'll start by defining two variables as constant integers: photo pin, which we've set to the analog pin 0, and LED pin, which is set to digital pin 9. Next, using the void setup function, we'll set the pin mode of a LED pin, which is digital pin 9, to output. And next, in the void loop, we'll start by making another new variable called integer light level, which basically will use the analog read function to get the value of photo pin, which is the value of A0. Next, we'll use another variable, integer brightness, and using the map function, set its light level to the 60, which is the low light level in my room, 750, the high level, and then 255 and 0, which is the range of the LED, which we can again see here in the brightness constraint brightness function, where we've used 0 and 255 as a range or the area which is constrained to for the LED. Next, using the analog write function, we'll use the brightness command, which we used here in line 11, to set the brightness of the LED. And to keep it all secure and stop it from crashing, we'll add a 20 millisecond delay. Okay, and if all goes perfect, we should have an output like this. Bright room has no light on the LED, and the dark room has a proper visible light. So now it's time to see a final result. For this, I'll be doing a live demo. So with the power of editing, we now have a live demo. For this live demo, I'll be using this torch and the shadow of my hand to replicate the transition between day and night. So we'll start by turning off the main power and turning on our torch. Next, we'll set the torch up right in front of this photoresistor over here. So plugging in the circuit, we see the LED has no light. But should we click this button and turn off the torch's light, we see the photoresistor notices the lack of light in the room and sets the LED to full power. I'll show it again. Torch on, LED off. Torch off, LED on. This is one of many simple projects you can make using the photoresistor. If you liked this project, do remember to like, subscribe and comment for more tutorials and to support small creators. Till then, this is Jappan signing off.